Hello, calculus fans. Let's find the length of this curve. It's got parameterization x equals e to the t cosine t, y equals e to the t, z equals e to the t sine t. And we're going to let t run from 0 to 2 pi. So we have our formula for the arc length. It's the integral from 0 to 2 pi of the square root of x prime squared plus y prime squared plus z prime squared. Now we've got to compute all these derivatives. All right, the expression is so long that I had to break it up into two lines. So what you should see here is that I've got a big set of parentheses here and here with a 1/2 power. So I'm taking the square root of a big expression. And then on the inside, what you should be able to see here is that this is x prime squared, y prime squared, plus z prime squared. I'm going to leave it to you to double check that all these derivatives are right. The next thing that we're going to have to do is try to simplify this whole mess. So I think things are going to get a little worse before they get better. We've got to square the x prime, and that's what you see here. So this is what happens when we square x prime. Here's y prime squared. Here's z prime squared. And again, everything is raised to the 1/2 power. That's just part of the formula for arc length. Now fortunately, there's some canceling that gets done. Like this cancels with this. And then what you should see is that a lot of other things combine together, that there are e to the 2t sine squared t and another e to the 2t sine squared t. And there's e to the 2t cosine squared t and e to the 2t cosine squared t. So everything gets combined, and we end up with this expression here. Well, everything simplifies very nicely. We get the integral from 0 to 2 pi of square root of 3e to the 2t. We'll pull the square root of 3 out in front, and then the square root of e to the 2t becomes just e to the t. Well, now this is very easy. Final answer, square root of 3 times e to the 2 pi minus 1. Okay, that's all for now.